Now that we've got all that done for the asymptotes, we're going to start putting things together and actually graphing the information that we have. So for the guidelines for analyzing graphs of rational functions, we're going to start with f of x equals n of x over d of x, again, numerator over denominator, where they're both polynomials. The first thing we're always going to try to do is simplify. So if we can factor and cancel some stuff out, we will. Then we're going to find and plot any y-intercepts by evaluating f of 0. In other words, we're going to plug in 0 for f, or into the function for x, and see what we get. Then to find the zeros, we're going to find the zeros of the numerator if there are any, and by setting the numerator equal to 0, and anything that makes the numerator equal to 0 is going to be a 0. Then we're going to find any zeros of the denominator, which is going to make the vertical asymptotes. So we have x-intercepts from the numerator equal to 0, vertical asymptotes from the denominator equal to 0. Then we're going to find any horizontal asymptotes using what we did a little bit ago, where we're comparing the n and the m values. Then we're going to plot some points between and beyond your x-intercept and your vertical asymptote. We'll look at that, what that means in a second. And then we're going to use some curves and graph the graph, or on the graph, to find our different pieces. So let's try this out. So starting off, we have sketch the graph of 3 over x minus 1. Now again, just like we did in the previous one, let's identify the degrees of the numerator and denominator. So the degree of the numerator is 0. If it helps you to think about this, 3 has no exponent on it, but it's like it's 3x to the 0. So that'd be 0 degree. The degree of the denominator is 1 because it's got x to the first. So for our y-intercept, let's start there. Let's set it equal to 0. So we have g of 0 equals 3 over 0 minus 1. We got 3 over negative 1, which gives us a y-intercept of negative 3. So as we're going through this, I'm drawing a little higher up than I need to be. Let me shift that on down. So we have a y-intercept of negative 3. So let's plot that on our graph before we forget. So we'll go down to negative 3. I'll do this in red so it's a little easier to see. And there's our y-intercept. Oh, this is different. Anyways, x-intercept, sorry. Set your numerator equal to 0. So in other words, what value of x makes 3 equal to 0? There isn't anything. So we're going to say there is none. 3 is never equal to 0. For our vertical asymptote, we're going to set our denominator, x minus 1 equals 0. And that gives us a vertical asymptote of x equals positive 1. So let's draw that vertical line at x equals 1. And I'm going to draw a dash on here. So you can either draw a dashed line, or if you have a highlighter, you can draw a highlighted line through x equals 1. I'm going to shift that over so it's a little more accurate. Sorry, it's being a little difficult for me right now. Okay, so there's our vertical asymptote. Now, a horizontal asymptote is going to be found by comparing the degrees of the numerator and denominator. The degree of the numerator is n, and we're going to say n is less than m. So going back a couple pages, if n is less than m, then the graph has line y equals 0 as the horizontal asymptote. So our horizontal asymptote is the line y equals 0. So horizontal asymptote on essentially the x-axis. So there we have that. Now to find some other points, let's choose some that are a little to the left of the x-axis, or the vertical asymptote, a little to the right. Let's try this out. So making a quick table, let's use a pen for that. We're going to plug in some x values, and then we're going to plug those into the function 3 over x minus 1. Let's just start by plugging in 0. So if we plug in 0, we do 3 over 0 minus 1, which would end up giving us negative 3. So we already have that. That was our y-intercept. Let's try negative 1. So if we plug in negative 1, we'll have 3 over negative 1 minus 1. That'll be 3 over negative 2, so we have negative 3 over 2. Now that's 1.5. So we're going to say right about there. Let's try x equals 2. So plugging that in, we have negative 2. I'm sorry, I'm going to the left. So we have 3 over negative 2 minus 1. So it's 3 over negative 3, which would give us negative 1. And let's do one more on that side. Let's do x equals -3. So we have 3 over -3 minus 1. Well, -3 minus 1 is -4. So we have 3 over -4 or -3 over 4. And that'll be about there. Now we're starting to get enough of a graph that we can start connecting the dots. And remember, this curve is going to get incredibly close to each asymptote. So as it goes further and further to the left, it's getting closer and closer to that horizontal asymptote. As it goes further and further to the right, it's going to get closer and closer to this vertical asymptote. Now let's try some on the right side of the vertical asymptote. So let's try x equals +2. So when we plug that in, we have 3 over 2 minus 1. So it'd be 3 over 1, which is 3. So at the point x equals 2, we're at y equals 3. Let's try x equals 3. So 3 over 3 minus 1, that'd be 3 over 2, so 1.5. Trying out x equals 4. It'll be 3 over 4 minus 1, which would be 3 over 3, which would give us 1. And you'll start seeing the same pattern that we did on the other side. Like if I were to go one more further, if we do 5, we'll do 3 over 5 minus 1, so 3 over 4, which would be 3/4. And we plot that there. So our graph looks something like this. We've got two curves, one that's mostly in quadrant, or that's completely in quadrant 1. The other one's mostly in quadrant 3, but it goes a little bit to the right of the vertical axis, or the y-axis, so it goes a little bit into quadrant 4 as well.